Let's get ready for our very first session. And for this, I'd like to bring on Rushi from Movement. Please give Rushi a big round of applause. We'll just make sure the mic's on.
Hopefully it's on. There we go. I was prematurely doing that.
So I want to cover a few things about what Movement is and how you're thinking about the future of developer tools and just smart contracts. But one of the interesting things to me is that you kind of recently, in the last couple of years, everything started. You dropped out. You raised a lot of money for the company. And it's been a crazy intense period of starting Movement. So tell us about how you got inspired to do this thing, and what was the founding story of you getting to where you are now?
I mean, we're in the Bay in Silicon Valley. It's a similar story to the other dropout stories. But yeah, I was always interested in distributed systems. I was the youngest hire at United Health Group, had a background in databases. Then started early on in a Cosmos ecosystem. Wasn't actually a big Ethereum guy because I was always like, I wasn't good at Solidity. I was actually really bad at writing Solidity. I kind of hated writing Solidity, so I started writing Rust. And I think we're seeing the market trend towards that. But yeah, November 2022, I was in college at Vanderbilt. I was like a broke college kid. And this article came out that said like Facebook was building a new language called Move. And their thesis was like, Ethereum was good in theory, but it couldn't scale to the point of which Facebook itself could use it. So they built a new language, a VM, called Move Virtual Machine. Now Aptos and Suite are the main L1s. Our thesis was we believe in Ethereum decentralization, we believe in Ethereum principles, but we believe alternative execution environments can scale. At the time, you obviously had Optimism and Arbitrum, but no one was talking about high throughput execution and having Solana-like UX on Ethereum security. So we started building Movement, the first Move VM layer 2 on Ethereum. So you can think of it like Aptos, Suite, Solana on Ethereum security, having all the benefits of Ethereum liquidity and ETH as an asset class, which is why we're all here, with the benefits of a high throughput execution layer. And I think we've come a long way and super excited to be here.
Awesome. I think you're going to set the stage for all the other questions I was going to ask. Which was really nice because we get to immediately flow into it. I also want to make sure that anytime we see a new terminology, we kind of get to explain that. So let's kind of cover what an alternate execution environment is and what are the nuances here that we have possibly heard of and how Movement defines it.
I like to say I'm the most unaligned layer 2. I was at Permissionless and was on the panel with all the other layer 2 founders, and everyone else has like used Ethereum for DA and uses EVM, which is what everyone tells you to do when you're building Ethereum rollup. But we're entering this part of the market where people are kind of fed up, per se, with the EVM. You look at what Solana's doing, you look at what Suite's doing. They have like tens of thousands of transactions per second in theory, averaging a few thousand, while Ethereum layer 2s are tapping out like 100 TPS. So there's clear discrepancy between like what Ethereum principles are and what use cases demand. If we ever are to opt for a world where we're actually having fully on-chain gaming and fully on-chain order books, the current state of the EVM, which is a single-threaded machine, which means, let's say you have 100 transactions, you're waiting for transaction A to B to C to D to finish, which is cool if you have like Aave and like 10 users, but when you're trying to put Facebook on-chain, it's pretty problematic. So the two main virtual machines are execution environments, which is where you deploy smart contracts, or the Solana virtual machine and the Move virtual machine. Solana virtual machine, obviously, for the Solana ecosystem, and the Move VM was designed from the DM project at Facebook. So high throughput execution simply means when you execute smart contracts, you don't have to wait for each contract to finish or each transaction to finish. You can execute transactions concurrently. That enables you to have higher throughput, faster execution, and a bunch of finality guarantees, which we can get into.
Awesome. So we kind of know that Facebook doesn't have a blockchain project right now because we don't see it.
Yeah.
And a big part of that whole movement was, hey, we're going to create a new way to think about this. We're going to think about scalability and safety. And that's where Move came from, as you kind of brought up. But we didn't really see a great future for Move from Facebook. What made you excited about Move specifically as a language, and kind of walk us through the decision-making of like what are the nice parts that others ignored or did not or overlooked that made you pick Move as the place to start everything on?
Well, for context, Facebook wanted to do the language, do the blockchain. It was actually regulation. Like the SEC was like, no, you can't do this. This is like fraud, or they had a bunch of lawsuits for the DM blockchain. Zuck was like ultimately like, okay, we can't do this, right? So like the whole DM program, that like $1 billion research, some of the best research in crypto today is coming from that original research group. It wasn't up to Facebook to disband the project. It was like Gensler, for better or for worse. I think we all have opinions, but I don't want to get sued. But my point is, like, Facebook had a vision, they couldn't execute on it, but we are an open source, decentralized platform, and we can bring that vision to life. The vision is high throughput execution, the ability to bring billions of people on chain without actually having infrastructure bottlenecks, but more importantly, security. I think security is a concept that goes underlooked. There's $4.5 billion lost, especially in the Ethereum ecosystem. Almost daily there's an attack between Arbitrum, Base, Optimism, Layer 1s. We've all probably been hacked, scammed, rugged at some point. The current state of blockchains is so insecure, where LPs, funds, institutions really can't do much on-chain DeFi action because there's risk of being hacks. Look at Kyber, look at Curve, look at sometimes Aave. There's even like attacks on Arbitrum pretty much every week at this point. The EVM isn't designed to be secure. So the Move VM brings formal verification, which is also part of the Ethereum roadmap eventually at runtime. So when you execute smart contracts, the ability to trust that they're formally verified, this type safety, memory safety, is very important.
So let's dig into that more, because I want to make sure that we kind of cover how security is defined here. So a big criticism of Solidity and what we kind of see in smart contracts is they get hacked because somebody forgot to handle an edge case and somebody found a loophole around it and they stole some money. You're saying that's not possible in Move?
Well, anything is possible, right? Move is not a perfect solution. What it comes down to is, like, I'm a bad Solidity developer when I was writing Solidity. I can't write perfect code. I'm sure there's phenomenal developers here, like, you know, PhD researchers. You will probably write perfect code. But for the average developer coming into the space, it's very, very difficult to write perfect code. There's always like integer overflows. If you look at the Kyber attack, it was like a 0.0001% attack vector where they, for one line of code, it was like 257 bytes instead of 256. So simple rounding errors, integer overflows can cause millions of dollars in hacks. And for the average developer, and even like products that are blue chip that have the 50th commitment of code isn't formally verified. So what Move does, it has a prover runtime that checks each line of code for resource, type, and memory safety. So when you execute code, it'll be like, hey, this module has integer overflow. You probably shouldn't compile this, and it'll flag it. Whereas in Solidity, the integer overflow gets compiled, gets deployed in mainnet, and then this North Korean hacker looks at it and like, hey, I can exploit this. So in the EVM, it's pretty easy to see when someone messed up and then go all in on it. Whereas with Move and Rust-based programming, these modules aren't possible. So you can think of it like an auditor at runtime. It's not going to be perfect, but there's over $2.7 billion now secured in Move and 0 hacks to date, knock on wood, which we're pretty proud of.
That's awesome. And are there any other features of Move that actually simplify this or actually help with high throughput?
Yeah, so Block STM is the main optimistic parallelization engine. Currently, like Monad, if you're familiar, and some of the other performant L1s are now pushing this research. But Block STM was built back in the DM days to bring optimistic parallelization. Look at the Solana VM right now. The main issue with their parallelization is that if you're a developer and you have 10 transactions queued up, you have to manage state kind of by yourself, and there's a lot of conflicts. With optimistic parallelization, when you're a developer, you don't have to worry about how transaction manage state. So you can deploy 10 transactions, and they'll optimistically parallelize, if you will. So TLDR, you have this parallelization engine within consensus and execution that enables you to have high throughput execution, not just of a 30,000 plus TPS, but in production, even if you do 1,000 TPS, that's records better than Ethereum Layer 2s today.
And I guess the nice part here is that you just deploy it, and that's part of the actual definition of the chain and the runtime, so you don't have to worry about any of these optimizations.
I think Move comes down to like DevX, right? If you're a developer, you shouldn't have to worry about, hey, is my contract going to get hacked? How is it going to manage conflicts with other transactions? You should just worry about your actual app. You should worry about being the biggest Tinder, the biggest Uber, the biggest Airbnb. You shouldn't have to worry about your blockchain. So the DM paradigm, the Move paradigm, is to just simplify DevX, enable you to go 0 to 1, and have the Zuckerberg experience. Zuckerberg was able to deploy Facebook in 2 weeks and gets feedback. That same app can't happen on Ethereum today because you have to get audited. It takes like months to write proper code that's clean. And then if you do get hacked, you lose your entire social capital overnight. So security is actually really important for enabling financial applications at scale.
100% agree. But I guess when you look at sort of entering this now where we kind of have the benefit of hindsight, how do you think about what does it mean to actually transition into this? Because we've seen Solidity get more and more prominent. There's anywhere from best practices now to just highly audited code that people get to import. And kind of now they're being presented an option to like reset everything, learn a new language from scratch, and hope that that ecosystem spirals, or sorry, like grows and doesn't spiral. Is that a tough choice for people? What's kind of been the feedback when you've presented this to a developer, and how are actual developers thinking about starting a new way to think about coding?
Well, I would disagree that Solidity growth is rapidly increasing. Most of the apps that are popular today are on Solana or Rust-based programming.
I'm not. It's like I'm not fighting you on this. I'm saying that it's growing because there isn't a second option, which is still considered growth. But at the same time, it hasn't been the case that there has never been a second option. We've seen a whole new plethora of L1s in the last 7 years introduce their own formal verification languages, or kind of just new way of thinking about improving smart contract development. But you've kind of seen a plateau on that. So granted, Move is a lot more flexible and better UX, but how have actually developers reacted to this?
If you look at the numbers, Move started off at 3.5% of monthly active developers. Today it's 7.5%, and next year it's going to be 13.2%. SVM developers have doubled since last year, while Solidity developers have remained stagnant. I think it's a little bit increase. So across the board, we're seeing this transition in global industry from Rust-based programming, A, because it's safer and better UX, B, obviously price action. When Solana goes up, Sui goes up, people are like, oh, the tech gets better. That's how it works. And C, we're seeing a transition from Web 2 developers. So if I'm a college kid, if I'm in the Bay, it's much more intuitive for me to pick up Move or Rust-based programming. A, because I'm writing Rust for like data science and AI models, and B, it's much more object-oriented, it's easier, and looks more like JavaScript than Solidity does. So the pitch to Web 2 developers is a lot easier. So what we're seeing is a lot of migrations from like JavaScript and React developers to the Move and SVM ecosystem, whereas Solidity still bears that kind of barrier to entry.
No, that's fair, because if you're looking at brand new developers trying it, then this is a much better, and that's their default experience, and that totally makes sense. Where does EVM fit into movement here? You said you were still a layer 2. Is there compatibility? Is there bridging? What does that mean?
I think we all believe in Ethereum as a global financial computer. It has liquidity. ETH as an asset class is meant to be around. But I think there's a lot to be done on how do you make Ethereum itself scale. I think it's proven that just slapping on the EVM on Ethereum doesn't provide much UXs. If you look at the Ethereum layer 2 landscape today, there's not much nuance between them, and compared to Solana, it's losing the battle. Now there's a new paradigm called alt VMs that are coming to market, which are bringing alternative execution environments that can scale. You have high throughput, you have formal verification, and you still leverage the security and asset class of ETH. So the way we look at it is we believe in Ethereum, we believe in it as a global financial layer, we believe there's better execution of programming paradigms that can scale Ethereum better than the old EVM. And even if you ask like the original EVM folks, they'll be like, it wasn't designed to really scale. It was designed more as a placeholder. So that's why you had alternative VMs come to market. And then I think the way we see it is like EVM compatibility is important. We have EVM interpreter. The best analogy I give is like EVM and Solidity is like a PHP, where like early Web 2 websites or whatever was built in PHP, no one liked building in PHP. I'm not sure if anyone has done it. And then JavaScript came to market, and yet React and Vue and all these wonderful frameworks, and you could build a website in an hour compared to like PHP's, God knows how long and difficult it was. Similarly, now you have Rust-based programming, which is similar to JavaScript. The two main frameworks like React and Vue are Move and Solana VM. So PHP or Solidity will always have a place today. You want to use Curve, you want to use Aave, you want to use Uniswap, that'll probably be the best place to use it. But if you ever actually want to use consumer apps that can scale to, my mom uses it, your mom uses it, our family uses it, it needs to be in a high throughput execution environment and a language that can support security. So I think that both will exist, but the mass adoption that we all claim to happen won't happen in the EVM.
That makes a lot of sense. I just want to confirm something you kind of mentioned. When you said you are compatible with EVM, is that implying that you can still run an EVM code contract on the move?
Yeah, we have an EVM interpreter, so you can write slowly script. It's similar to like Solang on Solana. It's not the best EVM. We'll say we're probably the worst EVM in the market, but the way we say is like, if you really are stubborn and you want to deploy your slowly smart contracts, we'll still support you. You won't have the same security guarantee as the Move VM, so we urge most of our developers to write Move, but we still believe in backwards compatibility where we acknowledge that Move is still nascent, Rust is still nascent today, but in a 5-year bet, we believe that's going to change. But today, it's still nascent, so we still want to provide some support for that.
Awesome. We've kind of talked about scalability, but do you kind of differentiate between scalability and modularity?
Well, I think modularity enables scalability, right? The ability to have alternative DA, for example. Right now, if we were to do a parallelized VM on Ethereum mainnet, it'd be pretty poor. You'd have like 200 TPS because quality data is still expensive, Ethereum DA is still slow, so that's why you need alternative DAs like Celestia, EigenDA, whatever, to enable you to have higher throughput execution. So we believe that modularity enables scalability. You can have alternative VMs, alternative DAs, alternative sequencers that enable you to have high throughput. I think Conduit just announced like G2 sequencer, which enables you to have a beefier and thicker sequencer that can sequence transactions instead of having a smaller full node. But I think across the board, we're seeing modularity everywhere. Like Solana has like 50 layer 2s now, whether or not they agree. Ethereum now has layer 2s, different DAs. Even Bitcoin has like layer 2s, and there's like Bitcoin DAs now. So across the board, modularity is enabling scalability.
But is there any direct focus that you have at Movement on this?
Yeah, we're focusing on alternative VM, right? We're bringing the modular Move VM. We have it on Ethereum. We have a team doing it on Bitcoin. We have a team doing it on Ton.
So it will be on multiple chains, not just exclusive to Ethereum.
Movement itself is only doing Ethereum, but we have a team called Nexia that's part of the ecosystem, a team called Tonic that's doing on Ton. So we're encouraging this language everywhere.
Oh, awesome. On Twitter recently, we've seen a lot of fights, so to speak, on just kind of definition of what does it mean to be decentralized, because you have to kind of, or the arguments have been, hey, the higher the scalability aspect of a chain, the less possible for it to be decentralized, and kind of vice versa, and you kind of have this inverse relationship. How do you kind of think about movements here on, hey, if it's going to be as flexible, as secure, and as scalable and high throughput, does that compromise on any value of decentralization?
I think one thing we focus on is finality. Like, we're looking at pre-confirmations. Like if you look at Uniswap's Unichain, they have like this pre-confirmation mechanism that uses their L2 security instead of L1 security. The thesis is the majority of users don't need L1 security. If you're playing a Telegram tap game, if you're like, I don't know, doing like a DEX swap for like $10, you're okay accepting L2 security. Whereas like if you're moving $1 million worth of like USDT, you probably want L1 security. So I think in the past, like Ethereum alignment meant you always need L1 security, but that means you have like 7-day withdrawals, you have like 30-minute ZK proofs that are pretty expensive. But now we're entering an era, and that's what we're focusing on. Is like there's a lot of use cases, and I'd argue majority of use cases are okay accepting L2 security with the pre-confirmation, and you can have fast finality, you can have these higher throughput mechanisms. But if, let's say, for example, there are users that need L1 security, you can opt them in. So I think security has now become, or decentralization has now become like an optionality, where some users don't really care about security and decentralization, economic security and decentralization. They just want fast transactions. So for those users, you can provide a certain service, which is like these pre-confirmations. And for users that are like, okay, I'm doing $1 million pool on Curve, I need L1 security, you can have them opt in.
No, I think that's a really interesting way of looking at it. It's awesome. Kind of my final question to you here is, we kind of learned about the nuances here. We learned about kind of what you're excited about, what you're building. But give us an overview of kind of the timelines on what's available right now, what's upcoming, how you're thinking about what people get to use and when.
Yeah, we have our testnet live right now, testnet.movement labs XYZ. We're helping teams raise, get to markets. If you're a builder and you're interested in building a high throughput app that maybe not be aligned, please reach out. And we have mainnet coming up end of the year.
Amazing. Well, Rushi, thank you so much for this amazing conversation, and please give him a big round of applause.
Thank you guys. Appreciate it.